Hello, everyone, and welcome. I hope you're all having a great past summit experience so far. My name is Andy Yoon, and I'm your moderator today. I'll be monitoring both the Q&A and the discussion. Please make use of both to send in questions over to Deborah or to chat amongst yourselves as Deborah presents her session. But without further ado, Deborah, the floor is yours.
Thanks, Andy. So welcome, everyone. I'm so excited that y'all are joining me today, and I'm so excited to be here. I'm actually kind of nervous, but I am excited to be here. So we're going to talk data integrity demystified. So let's get started. First, you're going to see this for all the slide decks. PASS really does have so much to offer. So definitely take your time, figure out what you can take advantage of. It's almost too much. So definitely take advantage of all that PASS has to offer. There's so much information. Next, this is one of the most important slides, session evaluations. All of us who are here speaking today and yesterday and all this week, we actually really care about what we do. We love doing this. We want to make sure you get the information you need to do your jobs better. And we can't do that unless we hear from you. So please, please, please make sure you go and you fill out your session evaluations by November 20th. So that way we have feedback so we can make these sessions even better the next time. We can improve as speakers, and we can really make sure that we know that we are telling you the information or giving you the information, the tools that you need so you can do your job better. Because one of the things I love about this community is how much we care and how much we want everyone to do well. So please fill out your session evaluations. So for those of you who don't know me, my name is Deborah Melkin. I work as a SQL developer. I mostly work with software companies, so I've pretty much done the gamut from designing work with programmers to do everything from design the tables to get them out the door and help clients as they have issues. So I've been doing this for about 20 years now. I mainly work with SQL Server, although I've done just enough with some other relational databases, just enough to cause damage. I mainly work with transactional systems, although I've done a little bit with marts and warehouses, just enough so I can do a little bit of damage in those systems too. It's been a crazy past year for me. I was named IDERA ACE class of 2020. I won Speaker Idol last year. It's kind of crazy, but I won Speaker Idol, and actually there will be a panel this afternoon in a couple hours with Denny Cherry and a couple of the other judges and me talking about speaking. So come join us. It'll be a fun panel discussion. Would love to see you there. And the even craziest thing that I think I can mention is as of, 12 days ago, or maybe 11 days ago, I got the email that I was awarded a Microsoft MVP in the data platform. So I am beyond honored and shocked and humbled to have gotten that award. So, but that's not why you're here. You're here to talk about data integrity. So what are we going to do? We're going to demystify it, because I feel like data integrity is this very vaulted word and has a lot of meaning to it, but it's really not that hard. And there are things that we do every day. It's the little things that we do actually that create data integrity. So that's what we're going to talk about. We're going to first talk about setting the foundations for understanding data integrity and the things that we do where we start from. Then we're going to talk about designing for the data. So how do we create our objects so we can enforce that integrity? And then the key piece is data integrity and performance, because there's a little bit of they go hand in hand. Performance isn't always about data integrity, and data integrity isn't always about performance, but the two definitely work hand in hand. And if you ever need to do something to make sure the two work together, or that extra argument as to why data integrity is important, maybe some of this will give you that little push that you need to help get to really enforce data integrity and to make the argument as to why we need to pay attention to it and build it in where possible. All right, so let's get started. First, we have to define integrity. So I'm an English major. I was in English history and stuff, so I like definitions. So let's start with a definition of integrity. And it's a big word. It's a very lofty word. So a couple definitions that I got here from Merriam-Webster dictionary. First, a firm adherence to a code of especially moral or artistic values. or incorruptibility. That's another big word, incorruptibility. An unimpaired condition or soundness. The quality or state of being complete or undivided, so completeness. And I think those three synonyms really apply when we think about what are we looking for when we talk about data integrity, incorruptibility, soundness, completeness, talking about that in terms of our data. So let's put the word data in front of integrity and let's look at that definition. And for this, I went to Wikipedia. The maintenance of and the assurance of the accuracy and consistency of data over its entire life cycle, and is a critical aspect to the design, implementation, and usage of any system which stores, processes, or retrieves data. So I would say there's a couple key points here. The accuracy and consistency of data over its entire life cycle. The idea that data has a life cycle. And it's funny because I've done a T-SQL 101 session where I've kind of talked about a data lifecycle, and I didn't even realize that it may be actually a thing. But it works because we start by creating data, inserting, we view our data, then we realize we have changes, so we update it, then we may be done, so we delete it, and then we need more data, so we insert more. But again, how data moves through what we consider those different points of the life cycle and making sure we're always being accurate and consistent with that data is a really key piece. But it's also the idea that it's critical when we talk about design and implementation and the usage of the data. So however we do all of this stuff, we need to understand what that data is and what that life cycle of our data is and how we can really make sure we know what it is. But if you wanted to simplify it, take it out of the definitions. For me, it's looking at the data that comes from a column in a table and say, what does it mean? I mean, we're looking at a value here and it says 1, but what is this 1? Is it, what does it represent? And how can I make sure that this value and whatever it represents always stays what it's supposed to represent? I'm not saying that value can't change, but it's still representing something. And we want to make sure that we can guarantee what it's representing is always what it represents. And that's what I think our goal is when we talk about data integrity. The other stuff is great from an academic level, and I believe it is part of the goal, but essentially it's I want to make sure that the data in my columns and my table are accurate and they can always stay what they're supposed to represent. So, why does this matter? A lot of times I kind of save this sort of conversation for the end of the session, but I think this case, we want to start at the beginning because these are our goals and this is what we're trying to achieve by all the little things that we're going to do to create data integrity. So first, the concept is garbage in, garbage out. It's one of those phrases that essentially says, if you put bad data in your database, you're going to get bad data out. So the idea is if you can do what you can to make sure you have good data go in, you're more likely to believe you're going to have good data coming out. And that creates trust of your data. If you can't trust your data, you're probably putting a lot of extra code in somewhere to try to deal with that. And it's hard because data is kind of messy. And so we're always having to do transformations and we're always having to try to weed out the bad data. But if we can establish a sense of trust, we put ourselves in a better position. It also becomes important because our data in that one column, that one table that we're looking at, that's not an independent piece of data. It's likely related to something else, other columns on the table, and then you have tables related to other tables. So your data isn't independent, and the meaning isn't just that one little cell by itself. So if we have good data, we can trust the data. We can now start creating that trust across because we can trust the other cells and the others, or I say cells, other columns another table because everything's interrelated. So now we're kind of spreading it out and really making sure that it's not just that one column that's good, other columns are good as well. Our data is accessed by multiple sources. And I feel like this is one of the biggest things that I come across when I try to talk with developers as we're creating objects, new tables, and adding new columns. And where do we create data integrity? And oftentimes I'll be told, oh, well, it doesn't matter because it's only coming from the application. And I'm constantly reminding them, it's not just the application which reads the database. The first example I usually bring is, how do we upgrade our databases? How do we deploy changes for our software? Well, usually it's through a script. Maybe it's a migration script. Maybe we do state-based changes and use DAC packs. Maybe maybe there's a reporting system somehow that's reporting off of the data that's not even going through the application. There's multiple ways to access our data. And if we can ensure that there's data integrity in our database, we can make sure that however our database is being accessed, we have good data. We can trust the data. And everything related to that data is still going to be intact. And we can ensure the accuracy of that data as well. And the biggest reason for all of this is we'll often solve problems before they happen. One of the things that I always say is you can create a lot of great code and it looks wonderful. But if you're always having to deal with all of the issues created by bad data and trying to clean up your data and create trust in it and do all of those funky things to make sure you have good data, your code is probably not as efficient as it could be. And when you start dealing with inefficient code, you start dealing with a lot of other issues. So if we could really make sure that our data is accurate, we have that data integrity in place, some of these other issues we may be fighting, or that we have these funky workarounds we have to do, and the problems they create, we start eliminating those from the process because we don't have to deal with them because we know our data is good and we can trust it. So now we can really move into setting the foundation. Any questions yet?
No questions up until this point, just a lot of good mornings from all over the place, including someone from Stockholm.
Wonderful. Hello, Stockholm. So that's awesome. So hope everyone's having all right, so let's just dive in. All right, so we're going to set the foundation here. So now we talk about the data itself, and we've talked about why it's important. So now we can really get our hands into the meat of things. So setting the foundation. So what are we talking about? The first place we do this is when we talk about how we're storing our data and where it's stored. Because first thing we need to do is, where's our data coming from, and how we create that and how we set that up is the first thing that we're going to do that's really important. So we store our data in relational databases like SQL Server, NoSQL databases like Mongo or Cosmos DB, data lakes, Excel, text files, and a multitude of other different sources. And I'm not saying all of these are databases because we know hashtag Excel is not a database, but we still read data from Excel. We still read data from text files. We put data in data lakes. And at some point, we have to understand what the data is and also what the format of that data is, because we need to be able to work with it. And if we don't understand the basics of where we're getting our data from, we can't start creating that integrity. We talk about NoSQL databases, how they're unstructured data. I've heard that that's really not accurate, but it's more of a semi-structured, because at some point before the data goes in, and at some point when we pull the data out, we understand what the data is supposed to be. That's why understanding where the data comes from and how it works is one of the first places we can think about as where we're building data integrity from, because we have to understand how the data lives in the, I don't want to say lives in the wild, but kind of how our raw data looks. And that's the first place we're going to create data integrity, because we're starting to define the structure of our database, and we're starting to understand the type of data we're working with. And so that's the very basic foundation that we're going with, right? That's the first place. We can't build integrity unless we understand the basics of our data and what we have to work with. From there, we start moving into naming conventions. And naming conventions are kind of very subjective, if you want to say, I would put it that way. It's really, everyone has their individual ways that they want to name their objects, how they capitalize or use punctuation. And when I say punctuation, I tend to mean underscores, not necessarily periods, because that's a whole other host of issues you want to deal with. But how are you naming your options? How does it look? Things like character limits. Oracle's, as of several years ago, I know that older versions, you had 30 character limits. Well, if you're doing something and it has to be supported across multiple databases, how do you deal with those character limits? Singular versus plural table names. Some people like using 3-letter aliases or other sorts of prefixes for their objects. And even in SQL Server, if you want to think about schemas, which create logical groupings of database objects, you know, these are all different things that how you name things, how you group things, it really matters. And in some ways, it's almost a visual thing. In some ways, it definitely gets into the definition of things. So what do I mean by that? Let's look at a couple examples. So the first one is kind of how you use capitalization and underscores, where you can have camel case namings where every word is capitalized. There's a modified version where the first word is always lowercase. You can have all lowercase letters for your names. You can use underscores between words. Um, Whatever it is, it's whatever's going to be easiest to read, whatever works for you, and whatever it is consistent for you. That's what I would argue with. I tend to go with underscore between words. That way, you can kind of see, depending on fonts, things look a little funny. For me, underscore between words is easy to read. Your mileage may vary, but whatever it works, just figure out what's going to work and be consistent with it. Another example to think about is when we talk about how we name things, we actually have a lot of characters, so we could actually name a table. Let's see how we do this. Okay. Supercalifragilisticexpialidocious is 34 characters long. And yeah, I kind of have to sing that because it's just too hard to actually say. Which also gets into one thing is a lot of times when we use our words, we're describing stuff to other people, right? It's not just what the code is, but at some point we have to read the code or we have to talk to people about the table. So we can have these very long extended names, but it's also for me, my big thing is, does this name really describe what's holding in this table? Or is my table really about a long nonsense word or multiple long nonsense words? So when we think about the words choices that we do, it's really important because then we can start defining things. For example, if you had an owner ID column and you used it in 5 different tables, you would assume just by looking at the name that owner ID means the same thing. But if it doesn't, this is when how we name things really starts to matter and making sure that we really have good descriptive names for our objects, for our tables and our columns. And of course, this gets into the fun debate of, do we use singular table names or do we use plural table names? Personally, for me, I prefer the singular name, not a plural name, because when I find I'm talking to someone or having to describe a single record or even multiple records, it's much easier to have the name in the singular version. And I know for English it works that way. I wish I was a better linguist and knew more languages so I could help translate it for those who aren't, where English is not your first language. So I apologize for that. But again, when I'm talking about a gadget table, I find it easier to say one gadget record versus one gadgets record. I just find for the description and as I'm talking about the data, the singular works better. Whatever it is, as long as you're consistent with it, I think the consistency is really the point I want to drive home. Because when you're not consistent, you can wind up with a table that looks like this history of names. And I'm always amused because when you're at a company for a long time, or the database is a legacy database that's been around for a long time, you can start identifying when the naming conventions shift. So, oh yes, I remember we switched to underscores as part of this hot fix here back in 2014. Or we went to all underscores with this release in 2018. And of course, anything goes in 2020. So who knows what matters? But again, then it comes into I have new objects, I have new data I need to add. How how do I name things? And it makes it harder. And then you start, you know, it makes it harder to understand what you're doing and how do you define things? How do you describe things? And I think that that term description, when we talk about naming conventions, that's why all these little details, they matter because we want to be able to describe our data accurately. And I'm a very visual person. I like looking at my objects. I like looking at my table names. I like looking at the columns and immediately have an understanding of what data is in that table and what data is in that column. And because of that, that boiling it down to that element, that's what I believe creates a data integrity by using a naming convention. We're creating easy ways to understand what the data represents just by looking at the names. And it also starts creating that consistency and a structure. And that's how we can give better definitions to all the things that are used in our database. So with that, we can start designing for our data. And so now we can get into table design. So I know when I talked about the data storages and the data engines, we mentioned multiple types of sources. At this point, I am going to really talk about relational databases. One, it's my knowledge. It's my bread and butter. It's what I know, and it's what I work with. I think a lot of the concepts that I will be talking about can be applied for a lot of those other structures. And I think it's important to understand what we're doing for relational databases in addition to those. But as you're working with those, it's coming up with those translations. So definitely, if you spend a lot more time working with NoSQL databases or data lakes, you're going to apply these things in however you do those with those data storages and how we work with those, especially if those have to interact with a relational database. Because again, everything's interrelated. And so we want to start thinking about those. But as I start talking about relational databases, what you're going to find is I'm going to be talking about the basic things that we do. These are things that you're probably doing all the time. But it's not just what we're doing, but it's always how we're doing it, and more importantly, why we're doing it. And I find when we talk about a lot of things, it's the why that's the most important. We can add all of these things, but if we're not thinking about that greater purpose of why we do it, I think we miss a lot of the basic things. But that's also the cool thing about data integrity. It's a big concept, it's a very lofty goal, but actually the implementation, we're already working for it with all the little things that we do. So we're going to start by talking about designing for the data. So we're going to start talking about table design because there are a bunch of different types of integrity as we start talking about design. There's also the concept of logical data modeling versus physical data models. And a lot of what we're doing is going to transcend both. There are a couple things which are different between a logical model and a physical model, but for most things, it's going to be the same for both. The reason I mentioned logical versus physical is because some of the phrasing that we talk about the integrity is brought up on the logical level. So we refer to tables as entities and columns as attributes. So you may see those interchanged a little bit, but for the most part, we're dealing with tables and columns or entities and attributes. It's all the same. So the types of integrity we're going to be working with, we're going to work about entity integrity, which is all about the table. We're going to talk about referential integrity, which is about those relationships between tables, and our domain integrity, which is all about the columns and about those attributes. So let's get started with entity integrity. And the first place we do this is we start talking about our relational database design. Are we normalizing our data or are we using star schemas? Because now what we're doing with this is we're starting to determine how we group those different pieces of data in our logical way. Because normal forms and star schemas are really logical constructs. So how are we designing our data? Are we doing weights for dimensions or is everything the key, the whole key, or nothing but the key? How are we grouping it? Because what this does is it adds an extra layer. We're providing meaning based on the column's role on the table. Is this column a part of our primary key? Or is it describing our primary key? Is it a measure on a fact table? Or is it a dimension to describe how we're breaking out that fact table? So really, we're defining the different relationships, and understanding those relationships is another way we're creating that data integrity. So how are the columns related to each other on the table, and how are the tables related to each other as well? So those relationships matter. So that's how we're creating that integrity. The next, you can't have a table and not talk about primary key constraints, right? It's it's not just normal forms and star schemas, but all of our tables have primary keys. We talk about that a lot. So that is the column or combination of columns that define the uniqueness of each record on the table. The key thing is all columns must be not null, and there's only one primary key per table. And I mentioned the fact that there's logical versus physical, because sometimes you will find that your logical primary key may not be your physical primary key. And we'll talk a little bit more about that in just a minute. So the biggest question I'll get sometimes for the question I'll have for developers as they bring a new table to me is I'll say, okay, we need to define a primary key. So how do we do that? So my question, and this is my tip, and this is my process for doing it, so hopefully this will help you as well. So my question is, for this table, what does it hold using one or two sentences? For me, this does a couple things. One, it really narrows down what that table is about and what it's holding. But if we don't know what the primary key is, it creates a really obvious way for us to figure it out. So let's say we work for a company that sells equipment to superheroes across all the comic universes. So what we need to do is we need to allow them to order their gadgets or their equipment. So we have this nice little gadget order form. So if you were to ask me what this holds, this says this is for a given person or and corporation, they've ordered a certain number of gadgets of a particular gadget on a given order date. So when I state it that way, it's pretty easy to see that these four columns make up my primary key. So now I know my primary key of the table. And so I've created a definition. So now I know that per an order date, person, corporation, and gadget, I can only have one line, one record in my order form. So, and that's the basic way that basic way that that a primary key creates its integrity. It's a clear definition of what each record is about. And all the other columns are going to describe my primary key. But we can't talk about primary keys without talking about a surrogate primary key, because they are all over the place, right? I feel like when a lot of the third-party data layers became, I don't want to say fashionable, but when a lot of them were being introduced and became very popular, about 10, 15 years ago, there were some of them that required that you always had a surrogate primary key, or rather a primary key that was an auto-incrementing integer, or some one column. This is where a lot of the GUID primary keys, I think, may have also come from as well. But again, it's that one singular column that's used as a primary key. But I take this word surrogate primary key, and especially the word surrogate, pretty seriously. This is one of those things that I will actually get on a soapbox to talk about, because I'm kind of surprised, but I'm actually kind of passionate about this one. I have strong opinions. So I want to talk to you about it as well. And this is definitely up for debate because, I think there are a lot of elements to it. But I want to start with this word surrogate and define it in English. So again, I go to my dictionary, and the two things that you find, it's that I think are appropriate here. One appointed to act in place of another or a deputy, and really this one that serves as a substitute. So a surrogate primary key by this definition is a substitute primary key. And I think that's a really important phrase to think about as we implement them. So when we're talking about a substitute primary key and we're talking about data integrity, we've talked about how a primary key can create integrity. How does a surrogate primary key, how do these create integrity? Do they? I don't think they do, because it's a substitute. It's a stand-in. We just talked about our gadget order form, and we talked about how what makes an order form unique are these 4 columns, this combination. When we look at our gadget order form and we have a surrogate primary key, we have this one column, this one ID column. When we think about giving the individual columns meaning and defining a gadget order form, I would argue that it doesn't necessarily do that. It stands in, and there's nothing wrong with having a surrogate primary key. Don't get me wrong, there are actually lots of cases where you do want a surrogate primary key. And we'll actually kind of touch upon those later too. But right now, as this looks, an order ID doesn't describe what an order form is. It's just a random number that we've decided has meaning by calling it a primary key column. So there's a phrase, if you stand for nothing, you will fall for anything. I like to adapt it for a surrogate primary key. If your surrogate primary key stands for nothing, your data integrity will fall. So I strongly recommend whenever possible, because there are cases where it's not. I believe that, and I fully support that. You should find some way to create a representation of what that logical primary key is. So you know what that surrogate primary key stands for. So we can still represent what the logical primary key and create that integrity into our database as well. How can we do that? Why, the unique key constraint. So it is our columns or combination of columns that create a unique set in addition to the primary key. It's not as strict as a primary key because it allows for null columns. And the more important thing is, by having unique key constraints, we recognize the fact there can be more than one combination on a table that makes each record unique. So those multiple conditions, sometimes you'll hear a unique key constraint referred to as an alternate primary key or alternate key, because if you didn't have that primary key, well, this unique key could be one or this unique key can be one. So we're defining all of those options in our database, and we can make sure that those unique key, all of the unique combinations for the table can be enforced, and the database can help make sure that those aren't violated. Now, there is a good question about unique keys, unique indexes. Are they the same? Are they different? Are they interchangeable? Because in many ways, when you have a unique key constraint, it automatically creates a unique index. So do you need a unique key constraint to have a unique index? Can you just have a unique index? The answer is it really depends. But a unique index has 2 additional features that may make it worth looking into, such as you can use filtered indexes. For example, if you have soft deletes in your table, so you just keep the record and you say it's no longer active, you can create the unique index and filter it based on whatever the criteria is to say, what are your active records? You can also use included columns. So this kind of gets into the performance aspect of your tables and your usage. So if you need to have a unique key index that's used frequently and an included columns help, you can use that. And so in that way, a unique index creates a very unique, I hate saying unique again, but it's an interesting option for creating that uniqueness and creating that form of data integrity. It's a much more minute way of doing it, but it's still pretty cool that it's an option. Kendra Little has a great blog post about this, and I've included it as a reference at the end of our slides. So I definitely recommend going and checking that out. So unique key constraints, how do they create integrity? Now we can create all the alternate primary keys for our database or for our table. So that way, if we have a surrogate primary key, we can still enforce the uniqueness of that logical key. So for our gadget order form, I can now create a unique key on those 4 columns because I can't implement it as a logical because I need to use surrogate keys by maybe it is our standard in our database. But it also allows us to enforce those additional business rules. So are there any questions before I continue?
No questions at this time, although everyone's been saying good morning and welcome. So it feels like a very welcoming morning session, that's for sure.
Great. So I'm glad to hear that. Hope everyone's having a good time. So let's keep going. So let's start talking about referential integrity. So there's one really obvious way that we create referential integrity, so we can create that data integrity, and those are our friends, the foreign key constraints. So they create data integrity by establishing the relationship between multiple tables. And so now we can ensure that the values in the field exist in the reference table. So now we're setting standards on the data that we allow in our columns. But more importantly, when we're talking about that data has a life cycle, foreign key constraints are kind of the first place that we start introducing that data life cycle concept, right? Because it's no longer just about how these two tables are related, but we start thinking about what happens when data starts changing, especially when the parent data starts changing. So this is where we have those cascading foreign key actions. So what happens when the referenced column in our parent table changed, or if that record is removed entirely? So are we setting the value to null? Is there a default? Do we want to just change the data automatically, or if the row's deleted, the child record's deleted, what do we want to do? And so it's no longer just about what happens when one piece of data changes in one table, but what the impact is for another. And again, that data integrity between the relationship of the two tables. So let's take our gadget order form and let's expand it out a bit. So now we can see the relationships to other tables. We've established there's some foreign keys here. So one of the things that happens is you're selling you're selling things, we're selling gadgets. Well, what if we're no longer sell a gadget? What does that mean for our order form? And how do we maintain the integrity of what that order form is? Well, we could delete the order form if we no longer sell the gadget, but we may need this for sales reports for last month. So does it make sense to delete the record? We could set the gadget ID to null, but then we don't understand what was ordered. How do we run reports about that? Do we lose information? Is there a default? Is there a, hey, no longer, we have a record in the gadget table that says, hey, this gadget's no longer available? Well, how do we know which gadget they ordered for? Because we're going to start lumping gadgets together that we no longer sell. And as I thought about this, it's really interesting because I'm looking at it from the child table, solving this problem. How do I maintain the integrity of my child table, my order form? When really the question or the solution may not have to do with that. What if I need a discontinued column on my gadget table? So maybe the parent table needs to modify. So it's interesting when we think about data integrity and where we look at it and what it means between the relationships. It's not always the child table that we have to modify. It may be the parent. And when we talk about cascading actions, we may not be able to put it in our foreign key constraint itself, but we have to acknowledge what that relationship is and what happens when things change so we can figure out where we need to build the logic so we can maintain the data integrity between these two pieces. So when we talk about integrity of the foreign key, just to kind of recap, we're ensuring that the data related to other tables is valid. And we're starting to define the rules for handling changes with a reference column so we can maintain the integrity. So now we're started talking about maintaining what the data represents as changes occur to our data. And I think that's the big thing, making sure that still maintains accurate and still maintains to be true. So that's how we really maintain our data integrity with that. So from here, we can really start talking about our columns and that domain integrity.
Hey, Deborah, before you jump into that, there was a
Sure.
question that did sneak in from the last segment. So I want to make sure that that's addressed before you get too far ahead.
Perfect timing.
All right. So isn't this unique key constraint called the business key in the data warehousing world?
I believe it may be. I've not worked too much with the naming conventions from the business world, but I believe that it's a business constraint. And a lot of times I find when you talk about those unique key constraints, this is where I have the conversations with the developers who are like, yeah, the application will enforce it because it's a business, just, they think of it as a business key, right? Because the business is defined, there are two parts where you have, um, the data layer wants that single primary key, right? So this is where you have that unique, that auto-incrementing identity columns. So we throw those on all the tables, make those our primary key. And so the developer's like, well, we have our primary key. Each record is unique. So we'll just have the logic in the application, our business logic, in the code. So this is where I've had the conversation, but we can put it in the database so we can help support the business code. So yeah, I would believe that some people do refer to it as a business rule or a business key because they, the business logic says this is unique. It's not necessarily the primary key or even the physical primary key, but it can be a business rule. So yes, I would say that's probably true.
All right, outstanding. So let's continue.
All right, so now we get to talk about the columns. And there's lots of little things we do with columns that create data integrity. First is talking about the data types. We know choosing the right data type is super important. There are people out there who have full 1-hour sessions at least that talk about data types, right, Andy?
Yeah, I may have a session about that.
Yeah. So as you guess, Andy actually does have a full session talking just about data types. And he's not the only person because there's so much more to about choosing the right data type than I can cover here. But I at least want to introduce the concept of why it's so good for data integrity, because we're setting the type of data we're dealing with. We're creating constraints on the type of data that goes inside the column. And think about that because, we want to say today is, I believe it's March 257, 2020. But let's face it, no data type is going to accept that. They're going to make it say that it's November 12th, 2020. But again, we've created that constraint. So it's valid data. But that's the other thing. We're guaranteeing valid data based on the data type. So if you had a date in a string field, you can't accidentally leave off the N0 for 2020 as a year, and now you have invalid data. So creating those constraints, it's guaranteeing that the data that we need fits the data type, or the data type fits the data, and we can make sure those definitions line up. So expanding a little more of tables that we have in our superheroes database here for our superhero equipment company, we can start seeing some of the data types that we have in place. We have a lot of things that are integers. There's not too much questionables, but I would argue that we may have a little bit here, thinking about our money data type. And when I created this data model, I used money to talk about the monetary exchange when we put bills on for our orders. But if we look at this, a money data type has 4 decimal places. And if we're dealing with things like securities and currencies and financials, stock market type information, we actually do care about decimal places to the 4th decimal place. But when we're talking about buying and selling things like, just general exchange of money for goods, we tend to think of it as 2 decimal places to the hundreds. So whether you're dealing with dollars or euros, it's how many cents. And we're not talking about cents to the 4th decimal place. We're talking about cents to the 2nd decimal place. So we can start questioning, is this the right data type for our data? Or do we need to make a change and make it a decimal, maybe 19.2 or however amount of money we want to allow people to order? How much money do we think we're going to get? Another thought is, I'm looking at my description over here, and I made my description for my gadgets to be 254. Yeah, that's kind of a head scratcher, and I'm looking at it going, why did I choose 254? And I know some places I've seen it, and it's just been some standard that developers came up with. And I don't want to blame developers for too much, but because I like developers and I think they're great people and I work with them all the time. I do pick on them a little, but it is bringing up these questions. Why did we choose this? Is our description really need to be this long? Again, 254 is a little bit of an odd number. Is that some limitation that I'm unaware of? But again, it's questioning how long is a description. So this gets into, where is this going to be used? What other pieces of information do I need to make sure my data type is correct? So it's definitely asking these questions and making sure that the data type we choose fits the data, because otherwise we're going to start having to deal with conversions. We're going to have, wasted space, different things to think about. But data type choice is one of the biggest things we can do to make sure that we put data integrity, making sure we know how much data we have to deal with and what type of data. And that's how we're going to create integrity. We're defining the type of data expected for each column, and we're ensuring that the data matches what should be there. The next one is nulls and not nulls. And it's funny because I've heard this used and described as a constraint. And I'm not, at first I was like, oh, not null is a constraint, but it kind of is on the most base level. So we're setting whether the requirement of whether an attribute has to have a value. So there are two things to think about. One, null is the absence of a value. So it's not just unknown. It's more than just an unknown. It is literally the absence of a value. It's a placeholder that SQL Server uses to say there should be something here, but there isn't. But there's also something else to think about. An empty string is not a null. And I think that's a really key piece of information to think about and what the implications are. Because I've seen where you can put an empty string in a date time field. And so you can get, depending on how that empty string is inserted into it, I've seen dates like December 31st, 1899. I've seen January 1st, 1900. And again, that comes from however that was inserted into the date time field. But again, you have an empty string, which is not a null. So you have to do extra work to figure out, is it an empty string? Is it a valid empty string? Did you actually mean it to be an empty string? Or did you mean it to be an absence of a value? And so this is where we get into all the tricky things that you have to deal with around nulls and not nulls. But it really is an important thing to make sure, is my data required for the column? So a couple things to point out here. If we look at our gadget description, oops, let's try this again. I've decided we don't need a description for our gadgets. Is that true? Is that not? How are we using it? Maybe we find that we're always putting descriptions in our gadget table. And really, it should be a not null field, because if there was no data there, maybe it blew up the application, and that would be bad. So if we know that a field really is required because of those sort of problems, maybe it shouldn't be null. Maybe we need to go back and make sure it's a not null, because, blowing up the application is generally considered a bad thing. The next one I will actually point out is back on my order form. Our corporation ID. It's a nullable field. Now, this is where everything starts building upon each other. When we talked about our primary key and thinking about what the logical primary key of our table was, we said corporation ID was part of it. And when you talk about a primary key, everything has to be not null, right? Here we're saying corporation ID may be unknown. Maybe you want to allow a person associated with a corporation to buy a gadget, but not associate that order with their company. For example, what if you wanted to attend Past Summit, but not have it associated with your company? You wanted to go as you, and you can figure out how company reimburses you later. Maybe you don't want to associate your company with it. So this allows that sort of option. But this is where the concept of why a surrogate key and creating the logical key with the unique key constraint can solve the problem. Because unique keys can allow nulls. So now we're still able to enforce logically what makes a gadget order form, but not violate our primary key. Why? Because one column needs to be null. And so we can still create that data integrity and still allow for nullability in the same thing, because sometimes that actually is what's defined. But it's interesting to think about how these little things build upon each other and how all of them together, now we're seeing those combinations really start creating the data integrity and really making it clear what the definition of an order form is and how my data is supposed to look. And that's really important for thinking about all of those different things together when we talk about data integrity. Not just, do I need to have value in this column, but but what does it all mean working together and with all of the other columns around it on that table? And that's how we're creating integrity. It's setting whether that field is required to have a value. It doesn't ensure that the value in the column is good. Again, example, empty string, but if you have to have a value, we can make sure it is there. So we're going to move on to a default constraint. So putting this together, I have a new appreciation of a default constraint in some ways, because I think we tend to throw default constraints on, oh, look, we allow soft deletes. So every new record is active. We're going to set it to on. So yay, we have a default on is active. But when we think about what that means from a data integrity level, it actually is kind of cool. So a default constraint sets the value for a column if we don't specify that value when we do an insert, because default constraints apply two cases. One, when you add them for an insert, and the second is when you do a foreign key with a set default cascade. So when the parent-child changes, you set the child to the default value. Now, if you're inserting a record into a table and you specify null for the value, that's what SQL Server will use when it tries to insert the record. So if you use null and you're trying to go into a not null column, it's not going to take the default for it. It's going to try to put a null in a not null field because it ignores the default because you said what you want that value to be. And that's what SQL Server is going to use. But the fact that we have a starting point defined for our data. So this is where we talk about the life cycle of our data. We've established a standard, a starting point for how that record, how that row, how that column migrates through its life cycle. For example, we talked about, you inserted data, you changed it, and now you're done, you want to delete it. If you're doing soft deletes, the fact that there is a starting thing, all records start as active. Maybe you have, and then by default. So that's our starting point. We've established the start of our cycle. Maybe it's a different sort of status, new, open, complete. All records added automatically are set as new. So we've established a little bit of a definition to what that column is and how everything works from there. And I think from that, it's actually pretty cool. Because again, it's not just this number thing that you throw on, hey, when you don't include the column, here's what the default value should be. It's adding definition to that column. And I think that's really cool, to think of it that way. It's just a little default constraint, but it kind of has a big impact on defining your data, especially if you create data dictionaries. What does this column mean? We have a starting point of where it is. And that's really important as you're starting to learn your data and how it gets used in your system. So that's how they create integrity. We're establishing that common known value for the field when that first record is inserted. And again, it only matters when you insert your data. It doesn't apply anything else. So the last one I want to talk about for domain integrity is our check constraints. So these are creating restrictions that go on the data that goes into your column. So we ensure that the data in the field matches a given criteria. The most fascinating thing, again, as I was putting this together and making sure I had all the information I needed and I was saying everything correctly, I discovered that a check constraint is not just on a column. You can actually create check constraints on a table level. So you can use multiple columns to create checks on and make sure that your record is valid. I think the example that you can find in the documentation is that if you're based on a country, which columns are populated or which columns have are populated, something along those lines. I have the reference to the docs in my reference pages at the end, but that's kind of a cool thing to think about. It's not just, is my column valid, but all the columns related to it. And so what we're doing is we're really making sure that we're defining things so bad data can't get into your columns. And it's kind of taking the concept of a foreign key. It is the same concept, except for instead of validating against another table, it's just what's in our constraints. So, and that's how we're creating data integrity. We're ensuring only the values we expect to find in the column are the ones that get put in there. So essentially, we're eliminating a way for bad data to get into those columns in our tables. So if bad data can't get there to begin with, well, we don't have to deal with it. And now we could trust the data in the column that is going to fit those valid values. So any questions at this point?
Let's check. Doesn't look like there's any questions up until this point, though, but this is another good opportunity for you to drink some more coffee.
It's always a good opportunity for me to drink some more coffee. I don't know what it is, you know.
And I'll shamelessly point out that you're rocking a SQL Saturday Boston mug.
Yes, I love these mugs. I love seeing them in the wild. So every now and then someone will post one. I'm like, yay. So yes. All right. So if all of these different ways that we establish data integrity up to now aren't enough to convince you to put these in your database, I mean, maybe you are, but maybe you get some pushback. Why are we putting this stuff in here? Maybe thinking about what data integrity, some of the implications on performance are, and maybe those will be those little extra arguments, those little extra pushes to make the arguments like, yeah, no, this is why we need it. But the first thing I want to talk about is a clustered index. And I haven't spoken too much about indexes so far. And this gets into the idea, is index really describing the data and making sure the data is representing what it's supposed to represent? Or is it really about the different ways that we select data out of the database? And the way we select does tell us a lot about how we use the data, but is it really making sure that the data that we have in our tables is accurate? Is it complete? I mean, we talked about a unique index, and I would say, sure, that can definitely fall under data integrity, but your regular non-clustered index, I think it's up for debate. But when we talk about clustering our indexes, that kind of becomes its own thing. And this is really where we start thinking about integrity or performance. Because what does a clustered index do? It defines the order of how the data is in the table is physically stored. So it's about how we're storing it on disk, essentially. So why am I talking about clustering index? Because it's pretty common to take our primary key, cluster it, and be done. Why? Especially if you have something like a surrogate primary key that's on, let's say, an identity column, that's our auto numbering. So whenever we insert into our tables, 1, 2, 3, 4, 5, we've got that on a page and it's nice and clean, and it should be creating less fragmentations on our physical disk, and that's all sorts of good things, the way page splits are done, so on and so forth, depending on your fill factors and all those other fun things. But let's say you have something like a person table, and people in a table, it's really hard to come up with what makes a person record unique. It just is for a multitude of different reasons. And especially, let's say you have, a million people in your, million records in your person table, right? It's going to be near impossible to have any combination of columns that naturally define how each person is going to be unique. It's not impossible, but likelihood is you're going to have an ID column, an integer. Let's say you have that identity column, the auto numbering 1, 2, 3, 4, 5. However, let's say that you find that you're frequently searching by the last name. Not only are you searching it by it, but you're also sorting by it. This is one of those cases where if your natural cluster is on an identity column, but the way you're searching for things, and maybe the rest of the data as well, does it make sense to cluster the identity column, or does it make sense to cluster the last name column? Because now we're not just thinking about what the data means, we're thinking how we use it. And I think when the usage of the data in the table is taking precedence, that's the primary cause. It's really not about the data integrity. What's the data standing for? What does it represent? Is the data valid? Is it complete? It's about usage. So is that integrity or is that performance? I would argue it's about performance. And it's not a bad thing to do that, but again, it's thinking about, is we're talking about data integrity. We're about making sure that our data is good and means something. Usage does indicate that, but really it's more about how we're pulling it out, not making sure that data is correct. So I would say clustering is really about performance. But this is not to say that the things that we do for data integrity don't help performance. We actually have a lot of different elements that actually get used by the SQL Server Optimizer, nulls and not nulls, primary key constraints, unique constraints, foreign key constraints, check constraints. Probably the only thing that doesn't have the word constraint that's used by the optimizer is a default constraint. Why? Because a default constraint is really just used in inserts when we're not specifying a column. But when we talk about performance stuff, I mean, inserts, you do need to deal with performance implications of inserts. But really, when we talk about performance and integrity, it's all these other constraints that really get used by the query optimizer to come up with better execution plans. In addition, there's a reason there are full sessions about data types and performance, because now we get to deal with the size of our databases and our indexes, dealing with memory grants, dealing with implicit conversions, and all of these have implications on performances. So got a couple demos I want to show you just to kind of get you an idea with it. I'm not going full dive. I don't have a very large data set, but if we think about what these mean on a smaller scale, you can imagine what they mean on that large scale and those real world implications. So I have a superhero database, and I will be making all of this available to you later. I have a GitHub, and you can access that through my blog. So when you upload, you can go there. We can find the session uploads later.
Hey, Deborah, before you start the demo, there is a
Sure.
question that popped in, so I think this would be a good time to quickly tackle that.
Yeah, it's a great time.
Yeah, Derek asks, do you find that the difficulty in implementing these ideas to maintain integrity increases on tables that maintain a history of changes of all the records?
Oh, absolutely. And this is where it's really understanding, goes back to what does your table hold, right? So I think some of this goes back to that. What is your table holding? If it's history tables actually are probably the most complicated ones for data integrity, because again, it's a history. So your data's changed, right? So, but you need to capture it at a point in time. And so again, this is what is your table holding? And that's why I always go back to that sentence whenever I work with a table. One or two sentences, what does this table hold? And if it's holding a history, well, you're not likely to be able to do referential integrity because you're going to have a foreign key to a table and the data may no longer exist, and that may be by design. So logging tables, history tables, those are ones where I find that, you really can't have a logical primary key for. Maybe you really almost do need a surrogate primary key for. But again, it's going back to understanding the data that the table is holding and figuring out which pieces of data if you can apply integrity to, great. If not, you can't. And so, yeah, history tables are kind of I don't want to say exception to the rules, but you definitely have to really understand the data that you're holding to really figure out what you can do. But that's a great question, though. Yeah, history tables are definitely difficult to deal with when we talk about integrity because everything changes.
Awesome. So nothing else is in the queue, so keep on going.
All right. So we're going to start with a basic query. We're going to talk about where we can see data integrity used by the query optimizer in SQL Server. So first, I have a DBO schema here, and I have my gadget order form. And I've defined that my shipping column, how much it costs to ship each item, I've decided that's a not null field. So I want to get some information from my gadget order, from my person, from my gadget table, a pretty basic query. And if I look at my execution plan, it's a pretty standard execution plan, nothing exciting here. So now I want to search for any null values, any case where my shipping is null. We know it's a not null field, but what if someone didn't? And so we said, hey, let's look for shipping is null. Nothing returned as expected, but SQL Server is smart. It says, you know what, we're searching against a not null field. I know this value can't exist. I'm done. I'm short circuiting it. We're calling it no records returned. So we've short circuited the query optimizer. It says, hey, it's a fast, it worked its magic much faster. So now let's talk about the primary key constraint. Same query, except for now for my person table, I'm going to look for a particular person and I'm going to search based on the ID. So we have 4 records returned. So now let's look at our query plan and let's look in particular to our person. We have a clustered index seek because I'm looking at a primary key and I happen to cluster my primary key. But when we look at things like estimated number of rows to be read, the value here is 1 because it knows it's a primary key. It knows I'm searching on it. It knows there can only be one value. So it already knows that my estimate is 1. So now we can start getting the cardinality estimates in play. So we can make sure we start using the right joins as we join this to other tables. So now we know primary keys are unique. What about a unique key constraint? So I'm going to I have a villain schema within my superheroes database because, villains and superheroes go together. So I'm going to create an equipment table and I'm going to load data from my clean gadget table. But notice I've allowed equipment name to be null because it's villainous. And I'm going to add a record in for that as well. So I have 34 records added. So when I look for that one unique value and I look at my execution plan, notice it is doing a scan of my clustered index and it's estimating 34 rows to be read because I have 34 records in my table. So, but we know based on the data we inserted, there can only be 1. But notice I don't have a unique key constraint on my name table. Now you can put, a null, one null value and a unique key constraint. So I can create a unique key constraint and I can run my statement again. And now we've done a seek because a unique key constraint is also an index. So it did a seek against my unique key constraint. And again, estimated number of rows is 1 because it knows there can only be 1 null value. And again, if you don't want to use a null, let's say we want to look for umbrellas. Anyone buying, can you buy an umbrella as one of the options? Trying a different option. Look, I've got one gadget of an umbrella. And again, it's an index seek. And again, it knows there can only be 1 value because, again, unique key constraint. It's probably using the same plan as before, but again, it knows only 1 value can be there. So that's how many, it already estimates that. So when we start expanding about larger queries and such, we can start getting that estimate to be correct when SQL Server starts figuring out what that plan is. So, all right, we don't need this table anymore. I'm going to drop it. Now let's talk about foreign keys. So foreign keys are one of those controversial things sometimes when we talk about performance and data integrity, because we like foreign keys because we like making sure that related data stays related to each other. But a lot of times people don't like putting foreign keys in. Let's say you do large loads. They don't like the overhead because a foreign key is going to check the other table to make sure that you're putting valid data in. So if you're doing large loads, a lot of people will just get rid of the foreign keys altogether. But SQL Server can use foreign keys, and it can understand the different constraints and figure out better query plans based on those foreign key relationships. So I have a villain gadget order form, which is not as nice and clean as my DBO version, but I'm going to join that to my person table. And right now, I don't have a foreign key from my villain gadget order form to my person table. So this is a pretty simple query. And actually, I'm going to do this so you can show the people as well. So again, I'm doing an inner join between the two, picking out some people from my person table and some people and some of the information from their orders. Now I look at my execution plan, I can see my gadget order form, and I can see my person. So now I just want to select from one of those 2 tables. And so when I look at my execution plan, It's the same execution plan we saw as before. So now I'm going to create my foreign key. There are 2 blog posts that talk about how a foreign key helps with execution plans. One is written by Grant Fritchie and another is by Hugo Cornelis. And if there's any 2 people who know, that you want to go to talk about execution plans, these are the go-to people. Definitely, they know their stuff. So their blog posts say you have a foreign key constraint, SQL Server will use it. So then when you run this sort of query where you have joins between tables and you're only pulling up from one, SQL Server will recognize that and doesn't call the other table. So that's what we're going to prove. But the other thing I want to look at with this foreign key is whether it's trusted, because that actually matters too. If you have an untrusted foreign key, SQL Server can't trust it, so it's going to make decisions on the execution plan based on that. So if I look, it is trusted. It's weird that it is not trusted is false. The double negative, same for is disabled. So I have a valid foreign key that I've just created. So now I'm going to run that same statement. Gadget order form, join my person. I have a foreign key, everything's good. I run this, I look at my execution plan and wait a minute. According to Grant and Hugo, this reference shouldn't be in my execution plan anymore. What's going on? Well, this isn't my villain schema. It may not be trusted. We may not be able to trust our data types, right? So let's see if that column is nullable. Does that make a difference? Yes, my person ID is a nullable field, and I'm doing an inner join. And an inner join means data must exist on both sides of the referenced tables, right? So if it's in the child, it must be in the parent, right? We know it because we have a foreign key, but the column's null, so it may not exist. So now the inner join has to work to say, hey, it has to do the filter. Does my gadget order form, if it's null, is there data? So what happens if we make our column not null? And I'm going to rerun the query, look at the execution plan, and person is no longer there. So as I said, all these little things we do to create data integrity build upon each other. So if we know that their data has to exist for their person, for our order form, so it's not null, and we know it must exist in the person table, SQL Server doesn't even have to do the logic for the inner join to do that filter because it already knows because it's not null and there's a foreign key. So now we have a better execution plan. SQL Server can skip things it doesn't need, and you can have better performing queries, better execution plans. So I'm going to reset my table to its villainous self so we can go on with our next thing. And yeah, I'm going to go ahead and drop my foreign key too. So it's fully back to its villain schema. So what about a check constraint? Let's do this quickly. I have a quick check constraint on my gadget order form for the number ordered. So I only allow orders, needs to be greater than 0 and less than 10,000. So I'm going to run these 2 together. So one where I'm searching for a number ordered that matches that criteria that I've set for the check constraint, and one where the value is too much for 10,001. And when I look at the execution plans, we found 2 records where I've ordered 4, and we have our standard execution plan. But now we can look for where the value is greater than the value of the check constraint, and same as the not null. It knows no value can be of what's been specified, right? 10,001 is higher than 10,000. So therefore it short-circuited the query. It didn't do any work. It just knew that nothing was going to be returned. So the last thing I want to talk about quickly is data types and implicit conversions. So we have our villain schema. And this is where we talk about primary keys and why we want unique keys is available. So we have down here, we have these order forms. And we see that order ID is unique, but we see a couple things here where it looks like these could be duplicates. If we had a unique key constraint, we could confirm that, yes, these are the same order, or that they're duplicates. But if it's unique, I only have 1. So now I've got more records than what I need. Why? Because I don't have a unique key constraint. I'm just dealing with 19 records here. Imagine if it was 19,000 and we had those sort of duplicates that we had to work out somewhere. And how do you determine which one is the duplicate? And that's where we start creating a little bit of problems and why those unique key constraints for logical primary keys are just as important as the physical primary keys, the surrogate keys. The other thing I want to point out is we have these warnings. We have implicit type conversions. So let's go over to our properties. We have things like cardinality estimates. Why? Because on my villain gadget order form, my gadget ID is not an integer like it is on the parent table. It's a varchar. So now I have to do a conversion. And when you do data conversions, you can't always use indexes. So now you're not getting the advantage of an index. Plus, we're having to do, we have an index here, but what if I didn't have this primary key on my gadget table? Let's drop that quickly. So now I have a heap, I'm joining to a heap, and when I look at the execution plan, I can create a hash match, which isn't necessarily a bad thing, but now I'm taking all the rows, creating a hash, and joining them together. So all these little things, I'm making SQL Server do a little more work than it may need to do. So this is just kind of a brush onto how data type conversions and making sure data types are correct and making sure all these little things are in place because they're going to help you come up with better execution plans. So I know I'm running short on time, so I just want to leave you all with a couple parting thoughts. Is data integrity 100% achievable? And there were kind of indications earlier of what my answer is to this. No. I mean, there are history tables. Data, real world data is messy. You have legacy applications. If you try to put data integrity in all of the places, you could break things that you didn't mean to break. I don't think it's 100% achievable. But it's worthwhile to figure out what exactly is needed to really create integrity, because once you understand that, you know how to understand your data and you know how to work with it much better. And you can start putting those little things in places, maybe bit by bit, because all of these are small things, but you can start slowly working towards making sure that you can trust your data, you have good data, and you've built data integrity in. So this one that we talked about earlier, we want to understand what it means and we can know what it represents. And it could represent something really important, like the number of royal tiaras I've ordered to make sure I had a good picture for this slide deck. No, well, yeah, I did. Okay, but again, this number has meaning, and I always want to make sure that number has meaning. That's what's important. As I said, I have a couple different references here. And I have an updated slide deck. It's not quite the one that's on Summit, but I will make these available through my blog and my GitHub. You can find it from there. But most importantly, thank you all so much for coming. I hope you enjoyed this. I hope you learned something. If nothing else, a new way to think about what you're already using. You have my information. Please feel free to use it. Also, if you're doing the Pass to Prizes, I have a QR code, so I'll give you a second to take a picture of that. And thank you all so much for coming. I don't know if there are any other questions or if I'm completely out of time.
Thank you so much, Deborah. That was a phenomenal session. Well done. So yes, there is a question, so I'll fire that over to you now. Mike asks, is a surrogate primary key equivalent to a unique identifier that's derived through multiple columns?
A surrogate key could stand in for the unique combination. But I think a surrogate key is a stand-in. So however you choose to define what that stand-in is. A lot of times a surrogate primary key is like that identity column, or I have seen it where it's a unique identifier column, which everyone's like, oh my God, a GUID primary key. I have seen those in the wild. So it's really a stand-in. If you want to have the stand-in be multiple columns, you can you could do that. But whatever it is, it's the idea that it's a stand-in column, however you choose to define it, or stand-in key combination, however you choose to define it. So hopefully that answers your question.
Awesome. I also want to call back to some of the fun comments that you had earlier. Jonathan mentioned that speaking on performance, one line of code to ensure data integrity in one of his scripts changed it from 8 minutes to 8 hours. However, that does go back to garbage in, garbage out, as you made the point.
Yes, exactly. And that's the whole thing we're trying to achieve. So, and again, this is why data integrity, it's the little things, but we really have to think about how and why we implement those and where it makes the most sense. You know, it's a goal to achieve, even if we can never fully achieve it.
And then Andy Levy made a point about how foreign keys are really great until you overdo it, and then it makes deleting some data impossible, to which I kind of came up with the idea of, you know what, I wonder if you could come up with enough foreign keys to actually create a pseudo deadlock to therefore prevent data from being deleted entirely.
Well, foreign keys also get interesting when you start thinking about cascading foreign keys, because you can create a whole series depending on how the branches work out. So when you delete it, you can actually create foreign key constraints violations based on a foreign key that also has cascading foreign keys up from that same parent table that you're deleting. But because there's no order, maybe one of the child tables gets deleted before the other parent table and the thing. So yeah, foreign keys, it's why they're kind of hard to work with, and why you can't always put it in the data. Sometimes it is hard to put in the database, but yeah, you got to think about how you're creating those, and cascading SQL Server does have things to try to prevent some of the some loops, and you know, if it creates strange loops, it won't let you create cascading foreign keys sometimes, depending on how it's set up. And right now I'm blocking on what the actual terminology is, but yep.
All right, awesome. Otherwise, we got a couple of thank yous. So what I do want to emphasize to everyone is please spend a minute or two to fill out session evaluations for Deborah. But also, if you wouldn't mind, just even in the discussion right now, if this was an awesome session, you really enjoyed it, just give her a quick +1. That'll take you all of a second or two, just so we can get a little bit of immediate feedback. So would
Yes.
appreciate it all if you guys would at least do that. Otherwise, we'll hang out for another minute or two, see if any other questions come into the queue.
Yes, and thank y'all so much for coming. Hope y'all are having a great past virtual summit or past summit from home.
All right, just keeping an eye on things here. Derek, I already answered your question in the chat, but yes, all of Deborah's examples are on her blog, or technically on her GitHub, which is linked off of the blog. Yep.
Yeah, and I'll be updating everything probably over the weekend. I don't know if I'll have a chance the next few days, but definitely by the weekend, end of the weekend, it'll be up there.
All right, outstanding. You got a number of thank yous coming in, and some kudos here. So that's awesome. You did a great job.
Thank you.
All right. The +1s are coming in now. Yeah, there is actually a little bit of a delay between when we see your chatter and that sort of thing. So that's why we're kind of stalling a little. And it looks like we are going to be kind of wrapping up here. So yeah, I think that's about it. So cool. I think we're done.
All right. Thanks everyone for coming. Have a great day.